In this video, we're going to see how you can deploy a smart contract on Hedera Smart Contract Service, plus interact with it in 10 minutes or less. We're going to connect to the Hedera testnet, then we'll write a simple smart contract and compile it using the Solidity compiler. Next, we'll take a detour to set up an RPC connection. Then we'll write a script that uses HSCS to deploy that smart contract onto Hedera Smart Contract Service. We'll subsequently invoke functions on our deployed smart contract and verify the results on the Network Explorer. Starting the timer now so that we can track how long it takes to complete the sequence. So we've already done the prerequisite steps. If you haven't, go back and do that one now. So we're going to cd one directory level up and into the HSCS directory. Then we're going to copy the .env file from the very first sequence into the current directory. Then we're going to do an npm install command. But this time it's an additional global installation of solc, which is the Solidity compiler. Let's close up the unused files and open up the HSCS subdirectory. Let's take a look at package.json to see what we've just installed. So we've installed a few modules from ethers.js as well as .env. So this time no Hedera JavaScript SDK. Let's open up the .env file so we can see that we've got the same one as before, and the RPC URL, which has been not set up until now, is that we're going to set that later on in this sequence. Let's open up mycontract.sol as well as the script file. So on to step one. We're going to be modifying the Solidity file, the smart contract. So there are two functions in it and a mapping. So in step one, we're going to modify this line of code where we take the input parameter of the greet function and set that inside the names mapping, where the key is message.sender, essentially the account that invoked this function, right? So that's the mapping where the key is addresses and strings are the values that are input via the introduce function, right, which has already been created for you. Right, next we're going to run the compiler, solc.js, right, so with the bin and the ABI flags, and that will output a .abi file, that's a JSON file with the interface, and the .bin file, which is the EVM bytecode that is executed by the EVM. Alright, we'll next set up an RPC endpoint, get that RPC URL. We'll do that by Archaea. We can sign in using Google if you want to. I'm not going to do that. I'm going to sign up by email instead. Alright, the sign up is complete, but the account still needs to be confirmed via email. So I'm going to do that off screen. Okay, we're going to refresh the page now, and the account has been confirmed. So here's what we're going to do: create project, then create a new project with some details, and then press the manage, and then get the required fields from it. Press create project. Project name can be anything you like. I'm going to use demo. Description, likewise, I'm going to use nil, and network is going to be Hedera. Press the create button, and then press manage. So firstly, we're going to select network, and from that we want to switch to Hedera testnet. Then for JSON RPC relay, we're going to copy that field and put it in the .env file. Just paste that inside there, replacing the existing value. And finally, we're going to get the API key. So copy that and paste it in the .env file, but put a slash between the URL that was already there and the API key. Right, so just want to emphasize that not to forget the slash. It's quite easy to miss. Note that Archaea is just one of multiple ways to set up a JSON RPC connection. Here is a list with all of the others. I'm going to unpause the timer now that we're back on the HSCS sequence. So time to write the script. So for step 2, we're going to use contract factory from ethers.js to initialize a contract for deployment. So we're going to pass in parameters of ABI, EVM bytecode, and account wallet. ABI and EVM bytecode are both read in from the files that were output by the Sol-C, by the Solidity compiler, and account wallet was initialized using the RPC URL that we've just set up, as well as the private key read in from the .env file as well from earlier on. Next up, for step 3, we're going to invoke the introduce function on the smart contract. So to do this, we're going to use myContract.functions.introduce and pass in a parameter of any string you like. Right, so I'm going to use BGUYZ. You can use your name or nickname. Any string will do. And then for step 4, we're going to invoke the greet function from the smart contract. So it's going to be quite similar, except that with introduce, we're updating the state of the smart contract, whereas with greet, we're just reading the existing state without modifying anything. So this function doesn't need any parameters, so we just leave it like that. myContract.functions.greet with parentheses. Now we're going to run the script. Alright, we've got some output. We can see that the output looks similar to the sample output in the sequence. And we can also see that myContractQuery result prints out what we expect, hello future, followed by the name or the string that you input in the introduce field. So that's what we expect. And let's copy the value of myContractExplorer URL, go to hashscan and navigate to that contract. So here we see that the contract has indeed been deployed. It has a contract ID as well as an EVM address. The EVM address matches the output from the script over here. And then we can take a look at all the transactions. The first one, the earliest one, which is the one at the bottom, we can see that this transaction is of type Ethereum transaction and it's got a child transaction of contract create, so that is definitely a deployment transaction. Now if you take a look at a contract result, we can see that it's succeeded, the from and to fields and the input arguments. Now you'll see that the input arguments is a very, very long set of EVM bytecode essentially, and this is from the Solidity compiler, right? So that's the entire EVM bytecode that was output. Now let's take a look at the most recent or second transaction. You'll see that this is Ethereum transaction as well, right? But there is no child transaction for contract create, unlike the last time. So that's that's when we call the introduce function, and we can see the input for it, right, is much shorter, and if you are keen enough, you can spot the exact hexadecimal bytecode. You can spot the exact hexadecimal bytecode for your input, in this case BGUIZ, and you can also see the contract state change as well. Right, so these are the checks that we performed, even the additional checks you like. All right, so I'm gonna stop the timer now. It looks like we've taken about 8 minutes to complete this sequence, which is great. So let's do a recap. First, we wrote a smart contract and compiled it using the Solidity compiler. Then we set up an RPC connection. Then we used Ethers.js in a script to deploy that smart contract and subsequently interact with it to update its state and query its state by invoking its functions. We also verified the deployment and the state update transaction using Hashcan, the Network Explorer. Thanks for following along. This sequence was one of several Hello World sequences. Do check out the other sequences too.